Hey class, so we are starting our new unit on thunderstorms. From here on out, we're going to be starting our extreme weather unit, kind of pulling all the stuff that we have learned about so far all together to understand this extreme weather that we experience. So this week we're going to focus on thunderstorms and understanding how they work, how they form, lightning, and all of that fun stuff. So the first thing I need you to remember is to recall on how clouds are formed. So we remember that the sun heats an air mass on the ground, and usually this is because of the unequal heating of the earth, because of the tilt of the earth, right? And this warm air mass begins to rise. And the reason why it's rising is because of this density difference that happens. As the cloud begins to rise, or the air mass begins to rise, the cloud begins to form, right? So we start to see this cloud once our water vapor, that gas state, condenses, meaning it goes from a gas state to a liquid state. Once this cloud begins to form, it continues to rise because of this density difference and because the air mass is a different temperature than the outside surrounding air. And it's going to keep on rising until this cloud reaches equilibrium, meaning that the air mass or the cloud has become the same temperature as the surrounding air in the environment. So in order to create a thunderstorm, there's really three main ingredients that we need. And this kind of combination of all of this helps create the perfect mixture for a thunderstorm. So they are moisture, lifting, and unstable air. So when I say moisture, I'm talking about the water vapor content. And the more abundant that this is in the air mass, the bigger the storm could potentially be, right? So as water condenses, it produces that latent heat. So as it goes from a gaseous state to a liquid state, latent heat, that energy is released. And because of that, it makes this air mass even hotter, making it more likely to rise to create a bigger cloud, right? If it's hotter, then it's going to take longer for that air mass to become the same temperature as the surrounding air. So the more water in there, that means that more water can condense, meaning that more latent heat can be produced, meaning that it's going to take longer for the air mass to achieve equilibrium and the cloud is going to be bigger. This energy, right, like I said, is used to increase cloud size. Lift is the second ingredient. And so what happens is the warm air mass needs to be able to be lifted off of the ground. And this lift is usually helping create this latent heat, right? So as the warm air mass rises and it's becoming part of the colder atmosphere around it, latent heat is produced. A lot of times this lift can come from mountains or buildings, right? Sometimes they act as a ramp, so air masses that are just freely flowing kind of act or slide up a mountain or a building, and they end up getting pushed up into the air. And because of that lift throughout, then that warm air is forced up into the colder part of the atmosphere where the water can begin to condense. Not only is it by mountains and buildings, but also cold fronts or other just fronts in general can also help push this air up. So you can begin to see that the cold air pushes a warm air mass all the way up, creating that eligibility for water condensation. The warm land and ocean can also give this lift, right? So if the land is warmer, right, absorbing that sun's energy, along with the oceans absorbing that sun's energy, this also gives off into the air molecules around it. And because of this, the air mass is going to begin to rise because of that density difference. For stability, for our last ingredient is, right, in order for the cloud to stop forming, you need to achieve equilibrium, which we know that if the air is unstable, meaning the air mass is a different temperature than the surrounding air, it is considered unstable. And with these unstable conditions, the bigger storm cloud is going to form. This is when the stability turns a cumulus cloud into a cumulonimbus, right? So the more unstable that it is, the more likely it's going to become a cumulonimbus, which, if you remember, cumulonimbus are your big storm clouds that we have. If the cloud grows into the stratosphere, right? So most of our clouds happen in the troposphere, but if by chance the cumulonimbus cloud grows so much because of this instability, it will then kind of flatten out and create this anvil shape. So you can see the picture that I've posted there, kind of flattens out at the top and creates this anvil shape. So once we have our three ingredients kind of all mixed together, there are different stages that the thunderstorm goes through when forming. So stage one is the cumulus stage. And this is just the very basic stage of just the cloud forming, right? A cumulus cloud begins to rise. You get this updraft, meaning that all of the air is pushed up, right? It is going up, and it begins to condense, creating the cumulus cloud, those water droplets. The second stage is once we have a cumulus cloud, what's going to happen is it's going to go into this mature stage, meaning that our cumulus cloud is actually going to turn into our cumulonimbus. So the difference really between the two, cumulus cloud and cumulonimbus cloud, is that it has these three characteristics. It has an updraft, a downdraft, and rain. And what that means is updraft, right, is that rising air. So the air and the air molecules begin to rise, creating, giving the water droplets, right, the water vapor, a chance to turn into water droplets. The downdraft is that actual falling action of those raindrops. So once the raindrops grow large enough, grow big enough on those condensation nuclei or anything like that, they begin to fall. And they fall along with some air as well. So the downdraft is the air and then the rain also. By this point in the mature stage, the cloud has become dark and gray. These are like the big storm clouds, obviously, that you see outside. And this is also where lightning begins to form. We're going to talk about specific lightning tomorrow when you get into your assignments with everything and how that forms. So we're just going to kind of talk about it later. And our third and final stage is the dissipating stage, meaning that the storm is now over and the cloud is kind of going away or dissipating, hence the name. So the downdrafts, meaning that rain or that airflow going down the cloud, becomes stronger than the updrafts. And because of this, there's no rise, right? So your air mass is no longer rising because of those density differences, those heat differences. And because of that, no water vapor can turn into liquid water. So if there's no rise, there's no rain. The cloud begins to disappear, starting from the bottom to the top. And then ordinary thunderstorms, usually this dissipating stage usually takes about an hour or so. The more severe, though, the longer it's going to take for this big cumulonimbus cloud to disappear. So it could take several hours, depending on how severe the storm was. Now, there are two types of thunderstorms, and it all is classified on how the air mass was lifted into the air. So the first type is just air mass thunderstorms, meaning that when the air is lifted based on orographic lifting. And orographic lifting, remember, is from mountains or buildings even, or from those land and sea breezes that we talked about before, right? So just natural causes of the unequal heating of the earth, and the air mass gains heat from either the land or lift from mountains or buildings, and because of that, it is pushed up into our colder, higher level atmosphere. The second type of thunderstorm is frontal thunderstorms. So this includes thunderstorms that were lifted up into the atmosphere because of a front. So there's cold fronts or occluded fronts that typically are the ones that create these thunderstorms. A warm front can create a thunderstorm, however, it is less common and less likely. And think about it, right? So we know that warm air needs to rise, right, because of that temperature difference. So what happens is during a cold front is that cold air kind of pushes under that warm air and forces that air mass to lift. And because of that force, right, these big clouds can form. Same thing with an occluded front, right? The even the warm air and the cold air are kind of pushing against each other, and because of that, all of the molecules can be forced up, creating these clouds. So take your time reviewing this video. If you need to pause, go back, do anything like that. I hope you took some good notes as I was talking. And then after this, you're going to go take a short quiz on Google just to review everything that you have learned. Thanks, guys.